Hey everybody, Adam here from Solid Smack. We're talking with Greg Mark from MarkForged, talking about these, I guess, multi-material 3D printers that he's been doing with Kevlar and carbon fiber and all that stuff. Do you want to tell us about that a little bit?
Yeah, so here's, just like you said, we have this part. This is a wrench that's reinforced as plastic, reinforced with full-length fiberglass, which makes it stronger than aluminum. So if you can break this with your hands, we'll give you a printer.
Oh, right, okay.
So,
right. So I'll just stand here and gnaw on this for a little while.
You try.
And see if we can do that, because I would like one
I did
of those
say
things.
break it with your hands.
Yeah, so, I mean, and this is, you said it's nylon, right? And
so
then,
it's a nylon plastic,
right.
And then kind of the same way that you have rebar and concrete,
sure.
we have reinforcing fibers that reinforce that. So you take that strength of plastic.
You can see that on this part, right? So you can see, like, I guess that's carbon in there,
Exactly.
right? And you're printing that, and you're binding it sort of with the nylon.
Exactly. So if you want to contrast these, here's a pure nylon part.
Yeah.
And it's very flexible. You can see it's just like plastic, like you'd expect. And then the carbon version with those reinforcements doesn't work.
Not possible.
Not amazing. Possible. Now, and the carbon isn't. I mean, the nylon isn't like intermixed with the carbon in there. It's just kind of around it, right?
It's used like the glue, so it sticks.
It kind of sticks to it.
Exactly.
Cool.
Exactly.
Top and bottom.
Exactly. And so actually, my friend's like with a good analogy. She calls it. So like what we print basically, it looks like a wood grain structure. It's just like wood, right?
Okay.
So this like continuous carbon is like wood, and then if you do like chopped carbon, it's like particle board.
Okay.
And like pure plastic is just glue.
The particle board is more like
particle board is
it's more like GFN, like a glass-filled nylon kind of material.
Exactly.
It's still stiff, but maybe not as stiff.
Exactly. So nylon's glue,
Yeah.
and then if you add like tiny, finely chopped like particles of fiberglass or carbon, you get particle board,
Right.
which is like 20 to 50% better. Or you go to like real deal wood, and it's like 5 to 10 times stronger.
Super strong.
Yeah. So
I mean, this is really impressive. These things are super stiff. You can't see it on the screen, but I mean, I could easily stand up. Like, this is hundreds of pounds of stiffness here. Really, really stiff.
So with this one, you have carbon.
Yeah, we got the material testing, all sorts of torture testing that we put this stuff through. Environmental chamber testing, like we'll do it. We'll do nasty things to it, like really cold, -70°C, up to 100°C, just to give it like a nice window range where like an engineer can make this part, use this part, and use it either like really hot or really cold.
Sweet. Now this is desktop machine. We'll be showing probably show some B-roll here in a second about showing the machine working and whatever. It's a beautiful machine, really cool looking. Now you were showing off in the
so you have,
opening session this morning.
You have the carbon fiber integrated here, but with this you have actual circuits inside the heel all through the sole here. So is that a different process, or is that taking place at the same time as the carbon fiber layout?
Great question. So we have in the software the ability when we click into the internal view. This is running live. So when you CAD this up in SolidWorks, you'll make a pocket for your part. So you do like an offset. You cut a pocket for it, and then at the top of that, when you're in here in the software, at the top of that layer, you just hit a pause feature. So when it's done printing the top of the cavity, you can drop your insert in, and then you hit resume, and it will like entomb it. So this particular one has a few layers of nylon on the bottom, base layer, then a whole bunch of rings of fiberglass for like extreme stiffness.
Okay. We
stopped the print like halfway through, so you could see the infill pattern,
right?
Which is all automatic. Then we drop this RFID insert in there, and then print over.
So one last thing I wanted to talk to you about. I mean, you're Greg Mark. You're the guy that started this whole thing, presumably. Tell us about that process. There's so many people out there that have ideas and things they want to get going. You started this thing. I mean, the first time I heard of you, it looked really slick. You already seemed to be off and running. And now this year, you guys are going like gangbusters. Your stuff looks amazing. Definitely check out the website, and it's just the videos are fantastic. And it just makes it seem like you guys are really, basically, you got your shit together.
Thank you.
Tell me about that process of starting the business. What was that like?
A lot of work.
Yeah.
Everybody talks about everybody tells you how awesome it is after it's successful.
Yeah.
But it's like, I mean, my fiance is a surgical resident. She works more than I do, but not by too much.
Yeah.
Right. She does like 110 hours a week. I probably do like 70 or 80. Wow. It's a lot of work.
And how did you? I mean, so you had this idea with your friend. What's the first step? How did you get started?
Good question. So this is my 4th time with the dance.
Oh,
so
okay.
like the racing company, we sold another company like power electronics to do the solar thing. So for me, like I went to some investors who I already knew and said, hey, look, I don't want to tell anybody about this thing. We want to develop it secretly for like very many months.
You have 3 previous MBAs.
Right.
Right.
Pretty much, right?
Yeah, yeah.
So it's like we want to do this very secretly, so write us a check.
Yeah.
Right, which they did. So when we debuted at SolidWorks World, nobody had heard about us, nobody had seen about us.
Wow.
We had lots of
How
time
long
to,
had you been working on it before SolidWorks World last year?
Like 9 or 10 months.
Okay.
So we had, and we had.
I mean, that's not a terribly long time to develop.
We work a lot.
To develop this,
We
yeah.
work a lot.
And how many people were working with you at
At
that
the time, there were like 6 or 7 of us.
And you were, presumably, able to feed yourselves, or at least pay your
Venture
employees during
capital
that time.
funding.
Yeah, I mean, you had you had
Yeah.
enough of it, fortunately,
Yeah.
to be able to do that,
Yep.
which is a pretty big luxury, I think.
It is. It is. The other thing though is we're very frugal. You know,
Yeah.
we put like all the money goes into the machine,
Yeah.
and so it's and we have a history of doing that. So the venture capitalists like write the check with a lot of comfort that like every penny that we give you guys, you know, we're not throwing crazy parties, we're not like out doing crazy stuff. Like we're like the money ends up in the machine.
Yeah.
Right. The money ends up in the software. The money ends up in the industrial design. Like that's what they want to see. And you get a track record of doing that, and people are much happier to write you a check.
So what piece of advice would you give to somebody who has an idea for a product that's complex like this, but you know,
Great question. Depends if it's software or hardware.
hardware, let's say. Yeah.
Okay, so hardware. So we did, because we had venture capital, we did like a self-hosted pre-sale campaign.
Yeah.
Right, which is great if you have the luxury to do that, right? Because the businesses that we're selling to don't buy things on Kickstarter,
Mhm.
right? So that's why we didn't go the Kickstarter route. If you have a hardware idea, honestly, Kickstarter is game changing, because it's when you look at like the design process, all the cost and money is going from prototype to production. We made that prototype, like the prototype of that, we made for very expensive. A lot of time, a lot of sweat, a lot of labor, but it's going from prototype to production. That's where the big money comes in, right? So with Kickstarter, you can you get to pre-sell, and not only it's like this is an amazing thing that didn't exist in my first business. The idea that you can start it, pre-sell it, and then not only do you pre-sell it and you get revenue to do all the tooling, which is the whole idea behind Kickstarter, you also get input. So we were here
Yeah, of
last
course,
year,
right.
and we show off the machine, and then we get all this input. We showed you the prototype,
Yeah.
right? And now people are like, oh, this is great, Greg, but I wish it did like these 5 things. And it's like, well, that's interesting, and like 2 of those things are in there now.
Yeah.
Right, so that when the actual
We actually
tooling
anticipated that.
When the
Yeah.
when the well no we didn't, so we incorporated that into the thing that shipped. So I showed you the prototype. I get feedback from you, right? And
Right.
the group of people like, I like this, I don't like this, I wish it did that. That's interesting. So now so this thing is like 2 generations ahead of what we showed here, and it incorporated a whole bunch of the feedback that people said, I really wish it did this, I really wish it did that.
Now, all of that seems like it would be pretty universal. Like that all applies to software as well as hardware.
Okay,
What's,
so
what's
the
different
difference
with software?
in software is if you have a software idea, just do it.
Just
Right, because you don't need
Yeah.
the expensive part of hardware is tooling.
Yeah.
There's no tooling in software, right? So expensive part of hardware, tooling, patents, like software, like you don't need
Launch
patent
it,
software.
get the
just
feedback
do it.
and
Just
iterate.
do it. With software, it either is totally awesome and it will just fly off the shelves. You have no problem making it. You have no problem tooling it. You have no problem it's just our software is like super slick. We recycle that really fast.
Right.
This is like version 1005 of that software, right? I mean, like they probably
Right.
have like I don't know, like more like 500 committed pushes. Like it just right. This is version 5 of the printer. Like we have an order of magnitude more releases of the software.
2 orders, 500
Right.
versus
you got
5.
it.
Yeah,
You got it.
totally.
Keeping me on point.
Yeah, well, math, it's a thing
Right.
that I
It's
do.
your
you
your
know?
thing, right?
It's actually not at all.
He's like, I can't back that
Yeah,
up.
okay. I don't have a leg to stand on. Cool, man. You got any
Yeah.
other questions?
Yeah. No.
Man,
This
Greg,
is-
thank you so much for your time.
I'll show you one other cool thing.
Oh yeah, please.
Okay, so we have the tooling and fixtures, right, and this like RFID tag that we want to embed in here. A couple killer apps that we didn't predict, which like customers like have told us this. Tooling, so like you can put this RFID tag in this tool. This is a fixture that is all printed except for this rotating piece.
Yeah.
You can put a tube in here and you bolt it to a table. It's a bend fixture.
Right.
Right, and so you can, for the French horn that we have in the original video, that guy is still making his French horn. It's like beautiful. We have great tooling videos of it at the booth. This is a mandrel around which you bend this thing.
Right.
Right. This is the 3rd version of this.
Uh-huh.
Right. So now let's say you're General Motors.
Yeah.
Right, and you're working the new Corvette, and you're using this as part of your assembly fixture.
Yeah.
Right. But now you're on the 3rd version, and you want to make sure that all your work cells have the most up-to-date version. You stick an RFID tag in it. So you can just
now you know which
zip,
one
zip,
is
zip,
the real one.
and make sure that
Right.
nobody's running. Otherwise, what happens the like old way, before you can embed the RFID tag in it, you just find out way down the line some QC guys like, we just made 60 Corvettes with the hole in the wrong place, right? Like that's a bad day.
Right.
Right.
Yeah.
This way, like by putting traceable tags in tooling, you can make sure your cells at the right rev. Number one. Number two, you can put that tracker at the door. Make sure your tools don't walk out the door.
Right.
That's a very very nice thing. The other thing, so the tooling is awesome. The other thing that we debuted at CES is, so we showed super lightweight, super high strength lightweight, like flying parts. We have like this stuff that's crazy strong. What we showed here, we wanted to show an example for consumers. Something that's like, okay, we have this new fiber, it does amazing things. I can give you lightweight, I can give you high strength. This is a totally new application where it says, this is an orthotic, this is made for somebody who rolls in.
Okay.
So the way people for the past 100 years have been doing orthotics is if you pronate, they'll shim it up.
Yeah.
So it's like you're
Right,
walking
sure.
like, okay?
With your feet.
Yeah,
cocked in,
very
yeah.
uncomfortable, not great for your knees.
Right, right.
So what we do is we say, we give you, like with everything else, we give you fit and form with plastic. And now we put this fiber at an angle, right?
So you get
now-
the stiffness right where you need it.
Okay, and now what we've done is when you roll forward, because this fiber reinforces in this angle, it rolls you, it corrects your gait.
Huh.
Right, so we make you this orthotic. So let's say you walk neutral, you don't have the fiber there.
Yeah.
It just rolls flat.
Right.
Right, but because this fiber's there, when you actually roll it, it pushes out. You're no longer walking on that weird hill. And so you try this and you're running at the running store where you're doing orthotics, and it's like, well, there's too much roll control. That gets 20 degrees. He's like, I want it off 5 degrees. Well, we have a CNC fiber machine.
Right.
Right? You want to take it off 5 degrees? We'll take it off 5 degrees.
Yeah.
And you come back, you're like, that was too much. I want you to add 2 back on.
Yeah.
You go through that iteration. Then when you get your thing, you got that for the rest of your life. You don't have to you don't have some custom operator. You don't have some oh hey, I'm just gonna smooth it. No, dude. It does the same thing every time.
They don't come out with a new version later and you're stuck with what everybody else is.
You don't. There's no.
Yeah.
It's like a CNC machine.
They don't discontinue your model of
Yeah,
the shoe, which
exactly.
happens to me all the time.
Yeah, exactly. So it's the thing that for mechanical engineers they expect this crazy repeatability.
Yeah.
But you go into an area like orthotics where we're just hey look, we'll give you CNC accuracy.
Yeah.
I mean our location is 6 microns. It's nuts.
Right.
Right. So it's that will be the exact same every time you make this. Right. Which is cool if you're a pronator it's
Yeah.
nice.
Fantastic.
We're working with some orthotics companies to do that. So it's kind of there's this new material, and again, we can give you strength, we can give you lightweight, but there's all these different applications that are springing up, stuff we never thought of, which is cool.
It's really inspiring, man. Thanks so much for your
Sure.
time.
It's a
Really
pleasure.
appreciate it. Yeah.
Thanks.